Hey, how's it going, everyone? I just want to do another installment in my Flat Earth Apologetics series. So we get a lot of stuff from ballers about explaining certain images. Why is the bottom cut off? And all that kind of stuff. And really, that's all they can sort of do. That's kind of off the shelf. Um, really, both sides right now. It's looks like Sly Sparkane's doing a test, and I'm going to post a video on that tonight, probably, but my commentary on that. But so these kind of, images and then seeing the bottom cut off is ball earthers' evidence of curvature. And so they'll often ask us to explain that on a flat surface. And so just something that I use, and again, this is just common sense, and it doesn't answer the question, but it gives us a way to kind of understand, the way our vision works, and then what we're interpreting when we see an image of any distance away. But so if the way I think about, what we ultimately see when we're looking at something far away, the way I build the image up is like, imagine you're standing on the shore and you're looking across a body of water and you're seeing, buildings or whatever. The way that, we're going to see the image, the way I construct it is I think about first looking down at your feet, right? And so the building is out there. So you look down and then you slowly look up. So you're going to go, and I, just to talk it out, the sequence of events that we're going to see, feet, shore, water, 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 building, 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 sky. And so that's kind of the way, that just talking through what we're seeing from quote unquote top to bottom, even though we're kind of making like an arc. But, that's what we see. It's like once our head is down and then lifts up, that sequence that we're seeing, that we're building up, is exactly what we see when we tilt our head up. It's just every degree that we lift our head up, we're just adding more and more to this image that we're ultimately going to be fixated on. And so this is the answer, and then the only debate now is, when do we start to see the transition between water and either shoreline or building? And so that depends, on a lot of different things, what's going on in the atmosphere, our own vision, whether we have a camera or not, the distance and our elevation and all that kind of stuff. But fundamentally, that's what's happening. And, to decide, why the water is quote unquote winning over the bottom of the, building on the other side, depends on a lot of factors, and so it's very, very nonlinear, and it's worse because it's also like time varying, because if you go and do that same experiment, on a day that's foggy or something, you may not even be able to see anything on the other side, much less the building. And so, that's what happens, and to me, that's really a difficult proof to use, because again, it involves so many different variables. And I think that ultimately all this stuff, this energy that's, being expended on both sides, the only thing that anybody can really kind of, hang their hat on is something that is either very, very close to linear or is linear, which means that it removes a lot of nonlinear effects. And our vision is nonlinear when we're looking at things in the atmosphere, through the atmosphere, and repeatable and observable, and so Sly's water bending test is close, something like that is good. My drones with the lumber and all that is, there's nonlinearities, but it's stuff like that. And I'm going to post another recommendation for, if people ever get the appetite to crowdfund a helicopter with a wide angle lens, and we scope out two buildings that, two high rises that people have access to the rooftops. We can use that and shoot light vertical, and then literally visually see the tilt. And so those kind of things, take away the, these optical effects, of looking at things from across the water. And to me, that's a good, obviously those are all really, really good. And, they can be construed to support one side or the other. It's one of the major things that got the whole flat earth thing going, it appears. But, to get something, again, like rigorous and conclusive, and all that kind of stuff, not time varying, is also very, very important. We'd have to start looking at different observations. But so just keep that in mind. If anybody asks, why you can't see the bottom of things, it's just, the water is sort of first, if you think of it that way. Again, if we're looking at our feet and then we're going to see the water, it's closer to us, for a certain amount of time, and then the building takes over, and so the water sort of loses to the building at some point. And when it loses, that moment, it varies, depending on, again, a lot of different things, on how powerful the camera is, if that's available, and what's going on in the atmosphere, what's going on with the water, and all that kind of stuff. And so, not trying to rain on really either side's parade, but again, something that's that nonlinear and also time varying can be good observations and a feather in the cap, but certainly not something that is absolute in my mind. But I just put that out there just as a way to walk somebody through that. And then if somebody claims to understand the math, to understand those transitions and be able to model those, it's a non-trivial thing to be able to do that. But if people claim to have the math to understand that, and then you can actually repeat it, that to me would be a very, very complex model, just because, again, the number of parameters that are involved when, looking at something through the quote unquote channel being the atmosphere is very, very multivariable. Hope everyone's doing well. Bye.